All right, so welcome everyone to the last and final session of our workshop. So it's the panel discussion. And as you'll see, our panel is composed of a very wide range of experiences. So we have PhD students, people ranging from PhD students all the way to tenured professors. We had already introduced Eiji and Pulkit. Eiji, do you want to join the stage? Yeah. Pulkit will join us shortly. I think he was being bombarded by students with a lot of questions. But please feel free to scan the QR code and enter your own questions, and we'll try and ask them. Yeah, and just to introduce the other panel members, I've already introduced Eiji and Pulkit, so I'll start with Priya. Yeah, so Priya is a third-year PhD student at Stanford University, advised by Professor Dorsa Sadiq in the Stanford Intelligent and Interactive Autonomous Systems Group, and by Janet Bogg in the Interactive Perception and Robot Learning Lab. Before Stanford, she completed her BS and MS at UC Berkeley, and she's interested in real-world robot manipulation, from improving low-level sensory motor control to developing better representations for high-level planning and goal specifications. We also have online Pablo Barros. Pablo, can you turn on your video, please? So Pablo, he obtained his PhD at the University of Hamburg in 2016, where he worked on cognitive robotics. He was also a postdoctoral fellow at ITT in Italy, working on cognitive neuroscience and deep reinforcement learning. In 2022, he joined Sony as a senior researcher, and his current research interests are cognitive robotics, affective computing, deep learning, developmental methods, and cross-modal learning. And we also have Jens Kober here with us. So Jens is an associate professor at TU Delft, Netherlands. He is a member of the cognitive robotics department at TU Delft, TU Delft Robotics Institute. His current research interests are reinforcement learning, robotics, and machine learning. I think many people will be aware of Jens here. So with that, I think we can just start with our first question. I think we'll start with a very contemporary question, and I think Pulkit was already asked something along these lines. So the question is, with the prevalence of foundation models, that is LLMs and VLMs, how do you see them impacting AI alignment and human alignment of RL and robotics in general? So anyone can start. Maybe Jens, you can start.
Sure. So in terms of human robots alignment, collaboration, I mean, the one huge jump, at least for me, was finally enabling interfaces that are very natural for humans and having means to translate those into things that a robot understands. Like Pulkit was saying, yes, for the more low-level things, the friction, the real contact stuff there, I think the jury is still out. If you're talking about higher level planning, coming up with sequences, coming up with higher level ideas and strategies, yes, there's still mistakes, but at least as a starting ground, that works amazingly well.
So actually, one of the things that some of my PhD students are often afraid of is they're afraid that they would replace reinforcement learning altogether at some stage. Do you have fears along those lines, or do you not think that's a valid concern?
I think there's still a lot of, like, at least so far from what I've seen, it seems like these VLMs and LLMs have really good high-level reasoning capabilities, especially for planning, say, sequences of skills. But I think, like, at the low level, there's still a lot of challenges in terms of actually being able to learn useful policies. And it's not clear to me entirely whether, say, even just like using VLMs and LLMs to define reward functions, for example, will be able to solve a lot of these tasks requiring more dexterity.
Thanks. So Pulkit, just to update you, so the question was, with the prevalence of foundation models, that is VLMs and LLMs, how do you see them impacting AI alignment and human alignment of RL and robotics? So Eiji or Pulkit, anyone can go.
Yeah, of course, I'm also interested in such kind of a large language model or foundation model to, but so today I cannot talk about some research projects regarding collaborating with companies. That is, the project is to transfer the skill, such as polishing the metal objects or stitching some crosses. So in that case, in particular, polishing the metal object is very specific skills. So and it's very difficult to collect the data itself. And even though we collect the data, so that data is very expensive. So the expert cannot open to be public.
Right.
So because it's quite expensive. And so in that case, so it's quite difficult to develop nice foundation models in that case. And also, even though we can build some foundation models, so we have a lot of things to do in the low-level control. So in particular, so we have to implement such kind of not only the position control, but also the force control, if it's a hybrid or something control. So in that case, so we have a lot of things to do, not only from the machine learning, but also control theoretic issues. So in that case, so it's quite interesting, but we have a lot of things. It's quite different from the languages and images. So.
Right, right.
So I think in principle it's possible, but that would require that the foundation models effectively represents a simulation that is indistinguishable from reality, and then we're in the matrix.
Right. So I think this aligns with a lot of some of the points that Pulkit talked about in his talk as well. Maybe you want to add something to that, Pulkit?
Yeah, just so that I am in the same zone. I think the question is about alignment of foundation models for robotics, right? Okay, yeah. So, I don't think large language models are going to replace reinforcement learning, and the reason is as following: that I think reinforcement learning for me is the process of data collection, and large language models are the way to consume data. So they really have different roles to be playing. Right. Then I think when it comes down to alignment, I think even if you look at ChatGPT today, that ChatGPT is the same for every user. And when we have robots in our house, we don't want the robots to be the same, but end up being personalized to us. In the same way, we would want ChatGPT to be personalized to different people, right? If there's a doctor going to ChatGPT versus a common man, if you say, I have a common cold, what should I do? The answer should really be different. Right now we have to do prompt engineering and be clever with it to get the response. It's not as intuitive. So I think there is lots of work happening in the LLM community for doing personalization along different axes of preferences. And in some worldview, robots are just a policy in the same way as an LLM is a policy. So hopefully those techniques should transfer. And once there is a robotics foundation models, we can just take the progress in that field and literally control A, control C, control V.
Right. Pablo, do you want to add something to this?
Actually, yes. I think one topic that might contribute a lot or be helped a lot by large language models is on the explainability side. Because nowadays on reinforcement learning explainability, there's a lot of solutions for that and a lot of ways to do it. But you always need an expert or to interpret it or to validate it or to deliver this explainability. While with these models, we might be able to create a layer to bring this explainability to a natural language. So use this as an interface to provide a better explainability to these models. Which of course then can be used to other things or finitude of things. But I think there is a big alignment, and there is a lot of people working on this already, and results are quite interesting. If you bring this closer to natural language. it has a big impact.
Right. Right. Thanks, Pablo. And Pablo, actually moving to the next question. You're the, I think, among the panel members, you're the one closest to industry. So I'm going to ask an industry-related question.
Right.
So is human in the loop RL mature enough to be used in industrial applications? Why and why not?
Can you repeat the question?
Is human in the loop RL
Uh-huh.
mature enough to be used in industrial applications?
Yeah. I mean, if you're talking about LLMs again, these models are trained with human in the loop. Huh? They are part of the training of this product, like we have nowadays, like ChatGPT and Gemini and whatnot.
I think the question was like not foundation models as such.
No,
but
I
just,
know. But if you think about these models as a product from industry, so this is an example. I do think that human in the loop is already used in some extent. If you look at recommendation systems, for example, that use reinforcement learning, human in the loop is part of it. But that demands a big data, very large amount of interactions, very large amount of user pools. Or if you are talking about personalization, it's still difficult in a product level to bring something meaningful without burning the user with too many interactions.
right.
So there, I think is still not we're not there yet.
Right. So your opinion is that if you talk about implementing it in like physical systems, it's not there yet. But
For personalization, and if you reduce the amount of
personalization.
if you reduce the amount of humans needed to interact with the system, it becomes more difficult. If you have a mass use system with billions of users, then the human in the loop makes sense because you have a lot of interactions to validate and to fine tune these models, right?
Okay. Anyone on the panel want to add to that?
I mean, to be a bit pessimistic, is there any
It's good. We
real
always need a conflict of opinions.
is there any real reinforcement learning in industry in the wild at all, let alone with humans in the loop? So I mean, it's always going to come down to how can you make it safe and provide some guarantees and make sure that nothing goes wrong. You can potentially do it for some, I don't know, recommender systems and try to learn from humans in the loop there where the consequences are not that drastic and you can control it. But as soon as you're really talking about robots that interact with the real world and can damage stuff, then it always gets very iffy.
Yeah, I think just building on top, right? So we know that at least some companies are experimenting with it. So Meta had the release where they were using reinforcement learning to recommend, posts, and the feedback was people liking those posts. And then if you follow, at least what's happening with animal or antibiotics, and even the most recent Boston Dynamics release of Spot, they both have included RL controllers as part of them. Boston Dynamics, specifically to go over slippery terrains. So I do think, and it's not RL with human feedback, but definitely there are places where RL controllers, both in the physical and digital world, are potentially entering deployment. Now, of course, you can question, what kind of deployment does Boston Dynamics have? And
Frozen and deployed are really learning in the world.
well, they have learned in the matrix, and then they have been deployed. Yeah, they're not doing reinforcement learning.
So they have been, they have learned and then tested and then deployed.
Yes.
All right. Yeah, that's interesting. Eiji, do you have anything to add? Or?
Yes, so so through the discussion with the people in the industry, so they say that so reinforcement learning is very appealing, but they believe that it runs like human. So it means that so only few trials, so they achieve the human-like behaviors. But so as you may know, so reinforcement learning usually takes a lot of training time. So and also the trial and error process is quite different between the artificial system and the real humans. So even though through the trial and error, so human behavior is very kind of directed. But the artificial system shows a very strange, stupid behavior during the training. So in that sense, so the industry people say that trial and error is quite important, but they're very conservative. So in that sense, kind of the learning range is quite limited. But there is a huge gap between the kind of such kind of trial systems, and also to realize that we need very strong domain knowledge to achieve such kind of directed exploration. But so we do not have such kind of prior knowledge to specific tasks. So therefore, in order to implement such kind of reinforcement learning or other kind of learning algorithms developed in the computer science in the industrial problems, so we tight connection of conversation between to fill the gap between the kind of such kind of issues. Yeah.
Anything to add, Priya?
I was just going to add that I think it's also quite domain specific. So for tasks, at least like from someone in industry, if you're constrained or you're not constrained anymore as much by compute or costs, then if you can just collect a ton of demonstrations for tasks, then why not just do that? Especially for settings like just arm manipulation. Whereas if it's like, and even driving, but if it's like, yeah, like Pulkit mentioned, if it's locomotion where it's very difficult to actually collect like sufficient data in order to learn from, like there's just so many different kinds of terrain you can encounter, so many different things. I think I do think that RL will be more important in those industrial applications, but quite domain specific, yeah.
Right, thanks. We have a couple of audience questions coming in, so I'll just read through them. So the first one is, considering that humans are also black boxes, can we really do better than rigorous testing for ensuring alignment or safety of our agents? So yeah, well, are humans black boxes? I don't know.
Yeah, so I think humans are definitely black boxes to some extent, but the verifiability is somewhat easier to do. For example, we can give a driving test to a human, and if they drive well in the driving test, there's a high confidence we have that they're not going to have an accident. But we do know, humans also, after having passed the driving test, may end up in unfavorable positions. I think the problem really is that our machine learning systems, if we give them some tests, the moment we evaluate them on something which is slightly different in the test distribution, we can't really say much. So to me, if we can bridge that gap, that would really be progress. And until then, I think it really has to be widespread regression testing. And I don't see a solution other than that, unless we are able to create this test suite or develop the kind of models which we can predict what the error rates are going to be on, starting from slightly out of distribution to more out of distribution evaluation.
So I'd also agree that humans are black boxes. For me, the big difference would be that at least we assume that humans can reason about consequences, and they also have some shared values and kind of know how to evaluate those consequences. While for an artificial system, kind of this thinking about consequences, I don't think is there yet, and kind of also these kind of ethics like reasoning things. And to properly do that, we almost need AGI.
And it's also not that simple because different cultural norms also come into play.
Indeed.
Yeah, I agree. I think I mean, humans is a black box, but there is more than that, right? I mean, the culture of the societal impact of it, and all of these enters into play, and all of these add some way more complexity than everything else on the system. So I think it's more than a single human if you're talking about reinforcement learning for big applications.
Yeah, yeah. If you have nothing else to add, we can move on to the next question, or do you want to add anything? Okay, we'll move on to the next one. So another question from the audience. Okay, this again, we're coming back to large language models, of course. So with hallucination in large language models, how can methods based on these models ever give safety guarantees to deploy them in sensitive applications such as autonomous driving?
I think all models are imperfect and some models are useful. So I think the question is, in what form do we think about guarantees over here? I think one paradigm which has emerged is of doing red teaming, where we try to automatically find, corner cases or edge cases where the system is going to fail. Now, if you look at least, I haven't worked in the self-driving industry, but when I, talk to friends after they're drunk, what they tell me is a lot of time is spent on really finding these corner cases, right? And when they find a corner case, they try to recreate this, scenario in simulation or in reality, and then test their model, add it back. And the question then becomes as, at some point you reach a scenario where each of these corner cases ends up looking different from each other. And then if you train on these corner cases, will it happen that you forget some corner case again, right? Do you end up in this whack-a-mole problem, right? And I think that I haven't seen a study which positively or negatively answers that question, because I don't think academic data sets have that property, that our corner cases are just so different. But definitely if the whack-a-mole problem is not there, then red teaming or automatic red teaming approaches could be quite useful, and the evaluation could be, if we did so much red teaming, then have we reduced the error rates from say 10 in a million miles, 1 in a million miles, or in case of LLMs, we could also get some scaling laws of hallucination as a function of red teaming, and that could be a path forward to build a practical and a useful system.
Actually, that reminds me of an important or an interesting question. So should the corner cases, the handling of corner cases, is that something that should be held or should be targeted by academia, or is that someone else's job? Are we leaving it to the industry people?
I think, so I feel like even with the existing VLMs that we have, there's a lot of cases where these corner cases could be anticipated better. So like a recent example I saw was there was a truck driving and there's a billboard with stoplights. And so the truck just kept stopping every 2 minutes. And I think there's, for example, in academia, one solution to this is that, we could, or from the industry standpoint, it's like you would just expect there to be a better VLM, but from an academic standpoint, there's probably better anomaly detection we can do, and not necessarily even needing to quantify exactly why the VLM is uncertain, but just being able to detect those as anomalous things, and then use that in a control loop where you would say slow down, and then use some offline classification or further queries with the VLM to be able to detect that could help. So I think there's things on both sides we could do, both in terms of data cleaning, in terms of people in industry who are training these models, but also having better anomaly detection in a safety critical system from the academic standpoint would be useful.
Yeah, I think that's a good answer, yeah.
And I think there's also quite a few more things we'll be doing in the future, like simple things like running two models in parallel and seeing if they agree or not, and hope that they won't hallucinate the same thing. Exactly. Kind of along the lines of what you were saying, actually figuring out what the true certainty or uncertainty of an answer is.
Right.
Yeah, of course, modeling is important, but so we cannot model everything perfectly. So so in that case, so we also have to consider how we should behave for unpredictable events. So therefore, many years ago, so control theory people proposed kind of robust control. So so there was very solid theory of adaptive control, which is very similar to the reinforcement learning. But so they found that that kind of adaptive control theory doesn't work in the real system. So therefore, so they gave up developing such kind of beautiful adaptive control theory, then decided to develop more kind of solid robust control theory. So of course, so it's not enough to in the current sense, but so we have to consider both in the both levels, so not only the robust issues, but also kind of such kind of adaptive issues. So in that case, of course, in both cases, modeling is important, but the point is that so predicting is not enough. So so when we cannot predict, well, we face some unpredictable events, so we should guarantee that such kind of how we behave in that case.
Yeah, I think I partially agree and disagree with 2 points which were made. So I think, on what Priya was saying, I think I agree that doing this anomaly detection and maybe if I were to rephrase that, representation learning for red teaming, I think is an exciting topic because we have done representation learning for finding similarity, but not for finding diversity. Right, this is what we need for doing red teaming. So I think that's definitely an exciting research area that we could tackle in academia. Now, I think coming back to Jen's point about having two models having different hallucinations, we have had these cases where the same input has fooled models which different initializations from ResNet to AlexNet and so on. So I mean, it is possible that the kind of uncertainty methods that we use when we have an ensemble, are quite challenged in the era of, deep networks. And, I always go, to my group and say, hey, we should have an ensemble. And none of my students actually trust any ensembles. So, I'm stuck in this dilemma. And I really hope that there is a good, method for quantifying uncertainty, especially in these, high dimensional spaces.
Right. Pablo, if you want to pitch in.
Yeah, I do think, I agree with I think most of the points. There is one side that academia can collaborate a lot on this is on the multidisciplinarity, which is not much present on industry because of focus and costs and whatnot. And that brings a lot of different ways to solve the same problem, right? Especially if you're talking about human in the loop. You have more than the human as a control system or as a predefined system. I mean, as we discussed before, human is a black box because of many reasons. And bringing this multidisciplinarity view on the topic, that really would allow us to develop these new ways of solving these problems in a much more novel way than just increasing the number of parameters or increasing the number of models or things that we can do now in industry, for example. So,
Right.
yeah.
All right, thanks. Okay, we have another question from the audience. Upvoted, one of the more upvoted questions. I don't know if this is really, I don't know if it fits into the context of human aligned RL, but the question is reward really enough for AGI as claimed by Silver et al. 2022? This is referring to the reward is enough paper by David Silver and colleagues.
Yeah, I mean, I would say we have existence proof that reward is sufficient in the sense that I mean, it could happen and that evolution was governed by principles which were not, the survival of the fittest. But if you were to believe the theory that life evolved, by, survival of the fittest, then definitely there is an existence proof. Now, will the same philosophy apply to our machine learning systems? I think it's a computational problem and also an environment design problem because it's very hard to think about rewards without the environment.
Without simulating, yeah.
Not even simulating, without the environment. For example, think about that there were, 1 million human on the planet and the food was abundant and it never ran out, right? Then even if you make the reward be food, there'll be no competition. Right, which might mean that we don't end up developing any interesting intelligence. The agents can just stop and be in one part of the world and just keep eating food.
Right.
But if you change the environment dynamics where the food is getting depleted, then the same reward function, which is, gather food, will force competition to happen, right? So I think talking and saying that, hey, it is just reward, I would say that's not the complete picture. So reward is always in context of the environment in which the agent exists.
Right.
So I think, yes, the reward can be survival of the fittest, but if the environment is boring, that will not lead to any good emergence.
So you would say a challenging enough reward or a challenging enough scenario would produce intelligent behaviors. Otherwise, no.
Yeah, I mean, there has to be some forcing function, right? I mean, we know humans are lazy, but so are our machine learning systems, right? I mean, they're also lazy. They like to find shortcuts.
Exactly.
And that's been the whole principle behind, self-supervised learning, that we want them to work harder, or why training on ImageNet with 1,000 categories leads to better features than training on 20 categories. Because when these networks have to work harder, they learn better features.
Right. Any comments from any other panelists?
Yes, so, as you said, so, I don't know the definition of the AGI in details, but, so at least there are so many neuroscience studies that shows that human learning is not necessarily reinforcement learning. So it means that, so we ask the human subject to do some task, then try to model the learning process by model of the reinforcement learning, but many experiment results show that the learning process cannot be explained by a pure reinforcement learning theory. So then, in that sense, so human learning process is much more complicated. So it means that reinforcement learning is kind of more, it's a conceptual model. So in that sense, so if one of the objective of AGI is to reproduce kind of human-like intelligence, I don't know the definition of human-like intelligence, but at least reinforcement learning is not enough. In that sense, I'm not sure whether the hypothesis is true.
Okay. Interesting points. Anything to add,
yeah,
Pablo?
I think in theory the argument is correct, but if you put it to practice, I think as was said, we cannot simulate the whole world and the whole complexity of the world, right? We have to transform this into a computational model. So there lies the problem, because then it's not a matter of learning, but maybe modeling or defining these interactions and these rewards. It becomes more than machine learning itself, the problem.
Yeah, all right. Thanks. We'll move to the next question. There's one other question from the audience. Many discussions were on human-in-the-loop systems. Robots are introduced to eliminate human involvement, but these systems reintroduce humans. So how do you see it moving forward? So I think the question, if I understood it correctly, is: are we ever going to have freedom from humans or is human in the loop here to stay?
I think that's very directed to the domain.
Yeah.
If you have humans, some part of it, then yes, humans in the loops are needed. If you need these robots to interact with humans or somehow learn from humans, there is no other way around. We cannot simulate humans.
Okay.
Yeah, I think I fundamentally disagree with the view that robots are there to replace humans. I think robots are there to augment humans. Okay. About the things that we don't want to do and don't like to do. And, for example, I don't like to do my dishes. So it's not that the robot is replacing me if it is doing my dishes. Yeah. Now, I think there are some, even if you look at, manufacturing and factories, and so many people are doing it because they don't have a choice, but if you're lifting these heavy boxes, 8 hours a day, those boxes are not heavy. Just imagine, you are in a car factory, a car is coming, on top of you, you have to put in a screw, and you keep on doing this action, for 8 hours. That's not what a human is about. I think human is not about doing repetitive things, just blindly and without thinking. So I think we should really have machines do what machines are good at and let humans do what humans are good at. And of course, I mean, I'll just stop there because there's this whole different discussion which might come in,
Right.
about, universal basic income or, what will people do?
Right, right.
But, I don't, we can get there, but I'll just stop, just to not take over.
Sure.
I think I'm very much on your side, and I would say that at least from many of the more interesting tasks where we actually want to have robots, there is going to be a strong interaction with human coworkers, with human clients. And one of the very obvious examples is healthcare or elderly care. But then also, if you're thinking about, I don't know, more flexible manufacturing, then there's going to be some interaction also, just given that as much as we dislike it, robots still are limited also in their capabilities.
Right.
I was also going to add for the settings you talked about with robotic caregiving, for example, like a topic that came up in the other workshops that I went to is that even if the robot is able to accomplish some task in a way that's, very, very good, like just things like feeding people, like assistive dressing, those kinds of tasks, I think for such human-facing applications, it also matters, like you want robot motions to be like perceived as human-like and also not scare people off. So I think it's a little bit scary to think about, especially those kinds of applications where we're in such close contact, not having a human in the loop, at least in early stages of deployment.
Right. All right. So I think we probably have time for just one more question. So I'll just go with one. Okay. What do you see as the biggest factors impeding human alignment and AI for robotics? Is it not enough human data, or the algorithms are not mature enough or general enough? Which is the most important factor is the question.
I think this human interaction is expensive from a computational point of view. You really need a lot of interaction for training and making an reinforcement learning algorithm works and explore everything, all the possibilities. And that's one big case.
So the human data is what you're saying?
Yeah, the human interaction itself, right? You need a lot of interaction to reach a point where a model can learn something. And of course, this can be shared among millions of users or simulated to some extent. But I think this is still the biggest problem.
All right. Okay.
Yeah, I mean, I would say, let's be honest, robots don't work today. So I think aligning robots with human feedback, I think, is a futuristic research direction, in my opinion. I think if you want to do, learning from human feedback, we should really think about LLMs and VLMs, because those models are ripe to tackle, and we can even study scaling laws and how much human effort is required to achieve alignment. And the hope is, the same scaling laws will also, transfer back into robotics.
Okay.
So for me, the biggest challenge is that this kind of human-robot alignment takes time to actually evaluate. And we can do our user studies maybe for an hour, maybe for a couple of days, but then kind of really to code learn in a sense, that might take months, if not years, and just evaluating that and seeing what works and doesn't, I have no clue how to do that.
Yeah. So evaluating them is a issue, you're saying?
But then maybe again, if robots are working and we have 10,000s of them, then we could do evaluation in a couple of days, hopefully, because the sample size would be so big. Or do you mean the learning process is still slow, so we'll still have to wait for a couple of months?
Also the kind of the humans learning how to work with the robots.
All right.
Yeah, point well taken. Yes, definitely.
Eiji, Priya?
Yeah, I think the biggest issue is that humans are very imperfect right now. So trying to have humans provide demonstrations or provide good signal for robots to learn from is still extremely difficult. So yeah, I agree with Pulkit's point about, can we use common sense reasoning capabilities from VLMs, LLMs to do better than that for now? And then, yeah, like Jen said, like have humans be able to adjust to robots and provide their feedback based on what they observe. Yeah, in like a continual learning loop or something.
All right. Eiji?
Yes, for me, so I'm interested in the kind of co-evolution of the human and robot in the human in the loop system. So in that sense, I need a more solid formulation, so in particular, so the objective function of the entire system is unclear. So, so roughly speaking, we believe that robot improves something and human helps learning of the robot system. But, so we have not yet established a kind of solid formulation to derive the algorithms for entire system. So in particular, so it's quite difficult to evaluate human learning process during the human in the loop system. So we can define something, but I don't know whether which is correct. So in that sense, we need more kind of formulation, or we need some good benchmark to evaluate such kind of human in the loop system. So
Okay. So I guess we've come to a consensus that it's the evaluation that's the main hurdle. All right. So I think we are running out of time. So we've been strictly asked to close before 5 p.m. So I think I'll hand over to Francisco for the concluding remarks. But let's have a round of applause for the panel members. And you can be on stage because we also have the best certificate, the best paper award. So it'll be great if you can hand them over. Yeah.
Okay, so we're gonna move Pablo though. Okay, just a quick couple of reminders. The first reminder is please remember to follow us on YouTube. Possibly we are going to be uploading the talks there in a couple of weeks from now. As I mentioned before, the last version of the workshop talks are already available in case you want to watch them. This is one of the reminders. The second reminder is, well, we are going to be in touch because of the special issue proposal in IEEE robotics and automation letter, sorry, too tired already. And I already mentioned at the beginning that we have a couple of certificates here for the best paper and runner-ups. So I would quickly call first to the two runner-ups certificate papers. So the first one is by Finn Ritz et al. The name of the paper is Towards Interpretable Reinforceable Learning with Constraint Normalizing Flow Policies. Is Finn here? Yes, come in. The second runner-up is for Niels Dengler et al. The paper is called Learning Interactive Viewpoint Planning for Foresight Object Discovery Considering Human Preferences. And the best workshop paper award is for Jorge de Heuvel et al. The paper is titled Learning Adaptive Multi-Objective Robot Navigation with Demonstrations. And last reminder, if you are not too tired, remember that we are gonna be heading now to a social networking event. So the idea is to have dinner there or maybe some beer, drinks, whatever. The place is shown there. It's called Gather at Eating House. So for the ones who are not too tired, you are welcome to join. We can go maybe, if you know the place great, it's just in front of APA Hotel. I know that there are many people staying there. If not, we can go all together from here, no? Okay, so thank you very much. I know that, well, last day conference at very end is very tiring for all of us. So I really appreciate that you stay here. I want to take the opportunity to say thank you to all the speakers, the panelists, the contributors, the authors, my colleagues as well. So thank you very much for joining. And well, we hope to see you in next ICRA as well, hopefully. Thank you very much.
Thank you for organizing.
No, thank you guys.